All right, pre-calculus, let's go over set C. So I pre-factored this one just to kind of speed things up a little bit. If I factor the top, I get this x minus 3, x minus 5. And factoring the bottom, I can factor a 2 out of everything and then further factor this into an x plus 1, x minus 3. Now, let's talk about what we, before looking at this, let's talk about what we do know from this. So the degrees are the same on the top and the bottom. So what does that mean about horizontal asymptotes? Them being the same on the top, that means that we look at the ratio of the leading coefficients, which was a 1 and a 2, and so that the horizontal asymptote will be at y equals 1/2. That's something, 1 over 2. 1 over 2, that's the ratio of the leading coefficients. Okay. Look at that. There's this and this that cancels out. So we have a hole. We have a hole at x equals 3. That's something that we see here. There's a factor on the bottom that's remaining. When x is equal to -1 on the bottom, that's where we will have a vertical asymptote. Okay, so that's a factor that's left over on the bottom. And then on the top, if we were to put in 0 for, if we were to put in, not 0, put in a positive 3 here and here, that would make a 0 over 0. That wouldn't work. But if we put in a 5 up here, 5 minus 5 would make 0 over something that is not 0. And so we would end up getting, our x-intercept, an x-intercept at, again, we want the result for an x-intercept to be 0. When we input a value of 5, that's an x-intercept. Is there more that we could get from this? So, where is the y-intercept for this? I don't know if they ask about this, but let's talk about it. The y-intercept is going to be what you get when you input 0 for x. So, well, let's do that in the original equation. 0 squared is 0 minus 0, 0. This all turns to 0, all turns to 0, and we get 15 divided by -6. So, 15 divided by -6, that's not the nicest thing. Well, you can divide a 3 out of it, and you get 5 over 2, and -5 well, that's not the worst. So -2.5 would be our y-intercept. Okay, so we have some information to think about here. Again, and kind of before I'm even looking at any of this, I want to even think about what's a mini graph for this look like. So at -1, there is a vertical asymptote. That's a very important thing to kind of think about. A horizontal asymptote, so if 1 is here, then at 1/2, there is going to be a horizontal asymptote. A hole at x equals 3. So at 1, 2, 3, somewhere up here, down here, somewhere, there is a hole. I don't know how to graph that because we don't have the other part of that. So we got the horizontal, vertical, x-intercept at 5. So 1, 2, 3, 4, and 5. There is a point, and a y-intercept at -1, -2, -3, -2.5 down there is our y-intercept. So when we're looking at this, it's kind of seeming like it's got some kind of, in order for this to kind of make sense, it looks like it's got some kind of shape like this in order to connect from this to this. And at 1, 2, 3, somewhere here, there would be a 0. So I'm gonna do a little bit of that. All right, that's what I'm predicting for that. On this other side, I'd have to do some thinking about. I feel like it would do this, but it could do something else on the other side. So let's jump in and see the domain. Okay, well here's the thing. What can't the x values be equal to? It can't be equal to -1 or +3. So x cannot be equal to -1 or +3, but it could be all real numbers. It could be all real numbers. So look at what we have here. We have this kind of notation here. So looking at this, the notation, it doesn't mention anything about the value of 3. So if we're going from -1 to +infinity, 3 falls in that range, and this fails. That part of this fails. So it doesn't really matter what the rest of it says. There's a gap in here where we have a value that it can't be equal to. All right, so the graph of h has a hole here. Okay, yes. that seems to be true. How would we know if it's at -1/4? Well, you know, we would actually just kind of like, we could plug values in and kind of see what it's approaching as it gets to either side. At that point, it would be undefined, but yes, that is true. That's where the hole is. All right. The graph of H has a horizontal asymptote. Nope, we talked about it. Horizontal asymptote is at 1/2. That one's not correct. It has a 0, has zeros at 3 and nope, it doesn't have them. It has a 0 at 3 and -1. That part is not correct. That is not correct. That's at 1/2. Okay, so the graph of H has a y-intercept at -5/3. No, we just did that. It's at -5/2 is what it reduces down to. So that one's not right. A whole lot of things that are not correct here. Oh man, light. Been in here over an hour making videos for you folks here. All right, so x is less than, all right, when x is less than -1, when x is less than -1, so this is area that we don't know about, the value of the function is greater than 0. Okay, this one is plausible. It's plausible. We kind of need to do a little bit of checking here. Let's take and put -2 in, and then way down the line, let's put in -10. All right, so what we're really doing is we're putting in -2 and -10 as x values and saying, what are our y values if we take the original function, either one of these? So it's like, take -2, put it in here, -2 squared. So, well, so we have to do both the top and the bottom. So -2 squared would be 4. All right, 4, and then -8 times -2 would be +16. 4 and 16 makes 20. 20 and 15. Well, that makes, yeah, that 20 and 15. That's the top number. That's 35. 35. So sorry. Now the bottom part of this is doing the same thing. Put a -2 in here. That would be 4 times 2, which would be 8. And -2 times -4 would also be 8. So we have 8 plus 8 minus 6. Ooh, so that's 16 minus 6. That would be 10. Here's the thing. When we do that, we're going to get 3.5 as a result. That means when we go here, -2, we're going to get a value of 1, 2, 3, 4, so 3.5. We'll get a value there. Now, if I get a value, when I go out to -10, if I get a value that's still at least greater than 1/2, that's going to prove to me that, yeah, that it's going to be greater than 0. It's not going to cross over. But if I get a value that's down here, then that means that it could cross over, and this could be false. Let's verify it. I'm taking -10, which is further down the number line, to kind of test its end behavior. -10 squared, that's a +100 times a -8, so in a -80. So 180, 195, 195 is our top number in our numerator. Now I need to do -10 squared, which would be 100 times 2, which would be 200. -10 times -4, which would be +40. So 200 plus 40 minus 6, 234. It doesn't really matter here. When I look at this and I do that division, I'm trying to see, is it going to be greater than 0? And it's like, yes, that's greater than 0. So it's going to, yeah. Oh my God, my brain is fried here. So let's do that. 195 divided by 234. So we get 0.83. So remember our horizontal asymptote was at 1/2, so 0.83 is still, it's greater than that. So all the way out here, it's still above this horizontal asymptote. It doesn't seem like it crosses it locally, so we can kind of assume that it's doing this, and it's doing that kind of shape, and we can assume that this is now true. All right, there's a lot to this. All right, the graph of H has a vertical asymptote at -1 and 3. So it has a vertical asymptote at -1 and 3. Well, we already saw that it has a vertical asymptote at -1, but at 3 it has a hole, so that part's incorrect. As x goes to -infinity, h of x goes to 1/2. That is true. That is the definition of this horizontal asymptote. That part is true. All right, as we're going further and further this way, it's getting closer to this value of 1/2. The last one, h is increasing whenever, when you're between these two values. Okay, so let's look at the graph between -1 and 3, and from 3 and beyond. So we're looking at the graph from -1 all the way to 3. That's all increasing. And from 3, not equal to it, but from 3 and beyond, yes, that's still increasing. So this last one is true, giving us our 4 of them that are true. You see how having a mini graph with this, first decoding it, taking it and factoring it, breaking it down, and then having a mini graph, how this is going to help answer all of these other little questions. All right, again, 11 minutes going over one part. This was supposed to take time in class. This wasn't supposed to be something that you'd get right away. You'd have to work at it. Take care.